Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about magnetic field due to a solenoid. What is solenoid? Solenoid is a long insulated wire wound in the form of a helix where the neighboring turns are closely spaced. This is the solenoid. Okay, the wire is to be insulated. Okay, clear? If you connect this solenoid to an external battery, there is a current will be flows. I am assuming the current flowing through this solenoid is like this. Okay, this is the way the current is to be flowing through this solenoid. So all the current carrying conductor produces magnetic field. So this solenoid also produces magnetic field. What is the nature of the magnetic field produced by this solenoid? We have to see it. I can consider this solenoid as number of closely spaced circular loop. Okay, so I am drawing like this, two closely spaced circular loop. This is one and the other one is like this. Okay, so each circular terminal produces a magnetic field. So magnetic field at any point in the solenoid is a vector sum of the magnetic field due to individual loop. Okay, so we will see this. This loop, this current carrying circular loop will produce a magnetic field. How? We can find out the direction like this. Curl your palm in the direction of current and the thumb will give the magnetic field. So this is the magnetic field due to this. Okay, and here what about this magnetic field? Like this. Here the magnetic field is like this. Okay, that means here like this. Okay, then what about this circular loop? This circular loop also will produce a magnetic field that we can find out by right hand palm rule. Okay, so curl your palm in the direction of current and thumb will give the magnetic field. So we will get in this direction. So this circular loop will produce a magnetic field. Sorry. Will produce a magnetic field like this direction. Okay. This direction will be produces and in this here like this, here like this. Okay, so you see here magnetic field produced by this circular loop and this circular loop are in the same direction. So vector sum is to be an addition. But this point you see here, magnetic field produced due to this loop is in this direction, this is in this direction. So something will be cancelled here also in the opposite direction. So here the magnetic field is reduced, here the magnetic field is reduced, but inside magnetic field is increased. So we can consider that inside the solenoid the magnetic field is uniform and strong. But outside the solenoid, the magnetic field is not uniform and it is very smaller. We are consider outside the solenoid, the magnetic field is 0. Okay, so how the magnetic field will be produces? There are number of circular turns are there. Each through the current is going like this. So you can curl like this. The magnetic field is like this. So inside we can get the magnetic field direction like this. Okay, this is about the magnetic field here inside the solenoid. Okay, what about the magnetic field here? Here the magnetic field is 0, here it is to be 0, but inside it magnetic field is not equal to 0. Clear? Okay. Now we need to find out the magnitude. For that I am changing this diagram like this way, that is, you see, okay, so from this, like this, it is coming and going into it, coming, going into it, coming out, going into it, coming out, going into it, coming out, going into it, the solenoid through the current. Okay, so in this magnetic field is to be acting in which direction? Like this. We can consider the magnetic field is like this. This is uniform and strong. Okay, I need to find out the magnetic field inside it. So I am using the law Ampere's circular theorem. For Ampere's circular theorem is applicable for a closed loop. Here I am going to take a closed loop like a rectangle. So I am taking a closed loop like this. This is a Amperian loop I am taking. I am going to name it as ABCD. Okay, Amperian loop. Okay, clear? And the current flowing through this is I. I is the current flowing through this solenoid. Okay, clear? Then, now we will see the Ampere's circular theorem. What is Ampere's circular theorem? Integral B dot dl is equal to mu 0, that is a closed integral B dot dl is equal to mu 0 into IN close. Okay, so first we will find out what is integral B dot dl. Integral B dot dl is equal to, I can write like this, integral A to B B dl cos theta, this portion integral plus this portion integral plus this portion integral and this portion integral. Okay, so plus BC B dl cos theta plus integral CD CD B dl cos theta plus integral dA B dl cos theta. Clear? Okay, now we will equate it. Integral B dot dl is equal to, what you will get? What about this value here? In this, the magnetic field is like this. The magnetic field is to be acting in this direction. What about the dl? Dl is like this. So here dl and b are normal. So the theta will be 90. So b dl cos 90. This will be 0. What about this? This is BC. Is there any magnetic field here? There is no magnetic field here. Here the B is 0. Here also B is to be 0. Okay? Then next, what about here? In DC. DC also perpendicular to the magnetic field. So here also cos theta is 90. So only this component is there. Okay? So we will see this. So that is equal to, we will get it as integral D to A B dl. Here this AD and magnetic field are parallel, tangent. So the cos theta is equal to cos 0. So we will get it as integral B dl. Okay, clear? So D. In this I can take the integration. So B I am taking outside. B into integration of dl. Okay. What about the integration of dl? I am taking the length of the solenoid. This length of the solenoid is to be taking as L length. Capital letter L is the length of the solenoid. If L is the length of the solenoid, AD length is to be capital letter L. So I will get it as BL, like that I will get. What about I enclosed? I enclosed. N is the capital letter N is the number of turns I am taking. Capital letter N is the number of turns of the solenoid. Total number of turns. Total number of turns. Then, what about I enclosed? For one circular loop, I amount is to be flowing. Then there are how many like that loop was there? N loop is there. So the total I enclosed, what you will get? I enclosed, you will get it as number of turns into I. That is the current through the one turn. Okay, now we will apply this to the law. What you will get? You will see this Ampere's second theorem we will apply. So that means what you will get? That is integral B dot dl, that is equal to BL is equal to mu 0 into I. What is I? Ni. Sorry, this is capital letter N. Sorry, this is capital letter Ni. Okay, then what about B? B is equal to mu 0 I N divided by L. What is this N by L? N by L is the number of turns per unit length. Okay, so we will take it as B is equal to mu 0 into small letter Ni. What is small letter n? Small letter n is equal to total number of turns per unit length. Okay, mu 0 is the permeability. I is the current flowing through the solenoid. Okay, this is the value of the magnetic field due to a solenoid.